to talk about aerospace technology, kites, and energy. But to explain why that's important, I would like to talk about Wi-Fi first. I think you all remember when we went from wired connections to Wi-Fi and we never looked back. That's because Wi-Fi gives you mobility, flexibility, and convenience.
Just go with this one.
We'll try with this new one, yeah? Perfect. And so, I mean, renewable energy has made major advancements in the last 30 years. It's now become economically viable to put them on the grid, but they're still confined to the grid. And once you build this turbine, it doesn't move. So now imagine that you are a mining corporation that wants to build a new site that has the power demand equivalent to 100,000 households. And it's a couple of 100 kilometers away from this grid. That will be very expensive to build this power extension, and it will take a lot of time. So what typically happens is that they get heavy fuel oil generators to power their mine. They're not terribly cheap or very environmentally friendly, but they are flexible. We want to make the next generation of renewable energy. We want to make mobile renewable energy. And to talk about how that's possible, let's talk about or see how a traditional wind turbine looks. So what's interesting is that actually the tip of the wind turbine, it captures 75% of the energy. Yet they only account for 1% of the mass of the system. So what we want to do is keep these wind tips and replace the rest with a string to the ground. And now I would like to tell you sort of the story and the progression we made towards this vision. So here you see the kite, which is the same as the tip of the turbine. And then the challenge is, how do you get it to fly in a pattern that you predefined? So first you need to know where the kite is. Secondly, you need a motor that can control it, so you can steer it. And thirdly, you need an algorithm that takes the information about where and translates it into actions on the motor. So the first challenge was to figure out where. And initially we put sensors in the kite that would then send information down to the ground. But since these kites move so fast that you need to do maybe 10, 20 changes per second. So if you have just a small brief connection loss, you crash the kite, so that wouldn't work. So the next thing was to make a visual system that could visually track the kite. That actually worked very well. Then the next part was the motor controller. You both need power and speed. So we actually also had to modify the control library for these motors to run twice as fast as they did previously. And then the last part was the algorithm. And we actually played around with a few different ones, but the one that we chose in the end is used for navigating trucks around the GPS waypoints from the Canadian Army. And that actually works. So here you should see, this is our first test of the autonomous flying kite. Yoo-hoo! Yeah, that's fine. So one thing is working with soft kites. The next part you want to do is have ideally a rigid wing kites. So the soft kites have the challenge when it's not windy, they just crumble and fall down to the ground. Secondly, they are not very robust, so over time they will probably wear out. And there's a few more, but so there's good reasons why you want a rigid wing. We did some mistakes, we did a lot of learning. Here it's flying in the end. Throw it in the air, captures the wind, and the wind takes it off. And this is controlled by RC remote controls. Very fun. But also, yeah, I won't tell you about all the stupid mistakes here. Then the next thing, a lot of people ask, how does it get off the ground? What happens when there is no wind? Well, to solve that problem, we want to use drone technology. So we learned how to build a drone, and this is actually the frame for the first kite that's flying indoors for the first time. It has a bit of torsional flexibility, but it works. So the next phase, now we want to combine all these rings. A control system, a rigid wing, drone technology to take off. And this is the first, no, it's actually the second test flight, but we'll go with it. So now it's hovering and now it's transitioning to flying in the wind. And as happens, and this is actually just one of many crashes, you do a small mistake basically. And in this case, we sort of reconfigured the kite, and then the rudder turns the opposite way as it intends. So it tries to fly up, and it steers even more into the ground. And even if we have sort of safety switches and whatever, I'm not fast enough to sort of react and save it. So it's built to crash, and that's why we built very small prototypes compared to pretty much all our competitors. They like to build large carbon fiber versions, and it's very expensive and time consuming. Anyway, so now it's actually time that we join E.On. And they asked us reasonably to start focusing a bit more on the customer development side. And this is one of the places we went to. This is a farm in a very remote piece of land in Eastern Africa. We met up with the girl, Catherine, that's sort of a very progressive farmer, and we met in middle of Nairobi. And what she would like is a system that can pump up water so that she can irrigate her farm. I mean, it's a very sunny place, but it's very arid. But basically this whole Eastern Africa, you could turn it into a major food source if you just had cheap energy. So that's a very interesting opportunity. And now for the final video, I would like to show you our two prototypes. And we're not only flying with one prototype, but we're actually flying with two prototypes because that gives you 4 times the amount of energy. Here you see the second kite goes up. And now they're just hovering, and then I'll flip a switch in a moment and they will transition into flying in the wind. So this is pretty exciting. This is the first time this is shown to anyone outside our company. Yeah, see what happens. They're flying, and now they want to catch the circle. Woohoo. So, and that happens, yes. So now they're basically both flying this predetermined pattern, and they are reducing the air resistance, so they're capturing more energy, and we are the world's first company to do so. Yeah, so this is our vision of the future of mobile renewable energy. And we want to do what make the equivalent of Wi-Fi for renewable energy. We want to make renewable energy that's mobile, flexible, and convenient. This is how it's going to look when installed in, let's say, Kenya. Thank you.